Single-mode fiber is constructed with a core that is surrounded by a cladding. Ideally, the optical properties along the x and y axes would be identical. If this were true, light coupled into the fiber with any polarization state would be output with the same polarization state. Unfortunately, there are always small imperfections and bends along the fiber that can randomly change the light's polarization state and orientation as it travels through the fiber, making the output polarization state unpredictable. A common approach to create polarization-maintaining fiber is to include two stress rods in the cladding. These stress rods are separated by 180 degrees, run along the length of the fiber, and exert stress on the fiber's core. This stress creates birefringence in the fiber core by increasing the refractive index along the axis that includes the stress rods, while having little effect on the refractive index along the orthogonal axis. Since light travels slower in a high-index material, the axis aligned to the stress rods is called the slow axis, and the orthogonal axis is called the fast axis. If light is coupled into both axes, the component parallel to the slow axis will be delayed with respect to the component parallel to the fast axis. Any perturbation to the fiber caused by mechanical vibration or temperature fluctuations will cause the phase delay between the two components to change, creating instability in the output polarization state. To maintain the polarization state within the fiber, linearly polarized light must be coupled into just the slow axis or just the fast axis, so the light only interacts with the refractive index along a single axis. And the output linear polarization will be the same as input linear polarization state under ideal conditions. And thanks for watching.